do a review of linear regression, and also we'll look at some of the problems that we've seen earlier in the chapter. So today's kind of a review day. So the first question, we're going to review slope and y-intercept in a graph, in a table, also in the equation. So let's start with the graph here. Let's find the slope and the y-intercept. So the slope, you pick any 2 points on your line, and this line is going down from left to right, so the slope is negative, and it goes down 1 over 2. So here our slope is negative 1/2. The y-intercept is the starting value, or it's the point when x is 0 on the y-axis. So here our y-intercept is 2 because we go up 2. In your equation, there's 2 ways to write this. We can write y equals 2 minus 1/2 x, or we can write this as y equals negative 1/2 x plus 2. So there's 2 ways to write this. Notice that the slope is negative in both, and the slope is next to the x in both. Create a table of points that are on the line for the graph and the equation to the left. So let's just go from, how about -2, actually let's go -4, -2, 0, 2, just picking some points here. So at -4, we go up 4 to be on the line. At -2, we go up 3. At 0, we go up 2, and at 2, we go up 1. So we've looked at a graph, an equation, and a table, and you'll be tested on that as well. Let's review parallel and perpendicular lines. So remember, slope is the number next to the x when y is by itself. So the slope of this line is 2. The slope of a perpendicular line, it's -2 because the negative is in front of it, so this is a -2. So then a perpendicular line, we're going to flip it and change the sign, so this would be 1/2, would be the perpendicular slope. All right, the slope of this line is 2/3, so a slope of a parallel line will have the same slope. And if it's perpendicular, you'll flip it over and you'll change the sign. All right, next we're going to review correlation coefficients. So you spent 2 days looking at this. So we're going to match these up. So this first one is kind of scattered here, and it's a negative correlation. So if I look at my options, the best choice for this one would be -0.6. This one has a positive slope, and all of the dots are on the line, so this correlation coefficient is 1. It has a strong positive relationship. This one has a strong negative relationship, so -1 is the strongest negative relationship you can have. In this one, they're pretty scattered. It's a positive relationship, but pretty scattered, so 0.3 is a good estimate for this one. All right, and then last, we looked at linear regression on the calculator, and you can do this with or without a calculator, but we'll try it with the calculator to find our line of best fit. You could make the scatter plot, draw a line of best fit, and so on, but we'll do it on the graphing calculator, and we'll use our equation to find the line of best fit and use it to make some predictions then of different values. So let me open up my calculator. So I'm going to type these in, and all the directions are here. So it takes a second to load here. Okay, so we're going to go home. We're going to add a new document. We're going to add a list and spreadsheet, and we're going to name it. And if we look at our data here, this is humidity, so I'll call it humidity, and I'll call this S for stars. And I'll type in these numbers: 84, 76, 79, 84, 76, 79, 88, 95, 82, 82, 87, 88, 75, 82. Okay, and then I'll go back up to the top, and I will type in the visible stars. We got 12, 22, 25, 15, 11, 19, 13, 18, 20, 22. Okay, and then we're going to go to Control Doc, and we're going to add a data and statistics page. We're going to add our humidity as the independent variable, the number of stars is the dependent. Okay, we can see it has a negative relationship here. The higher the humidity, the less stars you can see. Let's go to Menu, Analyze Regression, and choose a linear. So you can choose either one. The one I chose has the y-intercept first and the slope second. Okay, so let's write that down. Y equals about 67 minus 0.59x. I'll write that down. So line of best fit, y equals, and we have 67. I'll put 0.2 if I round. Plus minus is the same as minus 0.59x. Okay, so we can say here's our starting humidity, and then for each increase in percentage of humidity, it goes down, visibility goes down by negative 0.59. All right, we can use our line of best fit to calculate the humidity if 13 stars are present, and I'll go back to correlation coefficient in a second. And so now humidity, you have to figure out, is that x or y? And here it's the x variable, it's on the bottom here. Humidity is the independent variable, so times 13. So in our calculator, we can calculate that. You can use Scratchpad if you're in a graph, and just hit escape to get out of it. So do 67.2 minus 0.59 times 13. And if that's the case, then about 59.53 stars are visible. Oh, I did this wrong, didn't I? Because it says calculate the humidity, and I said 13 was the humidity. Let's try that again. So actually, I'm going to erase just a few things here. So we were given stars, not humidity. So if it's stars, stars was the independent variable, or dependent variable, and I'll put 13 here. And we're going to solve. Okay, so if it's this way, we're going to subtract 67.2 from each side. So in my calculator, I should have done 13 minus 67.2. And then I'll divide by 0.59. 0.059. So let's try this again. Okay, so divide by 0.59. Keep writing the wrong thing here. 0.59. This is what I should have written here. Okay, equals 0.59x divided by 0.59. All right, so let's type that in. Here we are. Okay, so divided by 0.59. And we can see, oh, it should have been negative. So if I would have typed that in, negative 54.2 divided by negative 0.59, then our humidity is high. It's 91.86, so about 92 is what I'll put. So this should have been negative, and x is about 92 degrees humidity. Now that correlation coefficient, we can see if we look at our graph here, that it's going to be not as close to 1 here. To calculate, let's hit Control and arrow over to the first page. We're going to go to Menu, Statistics, Stat Calculations, Linear, and select your X, which is humidity, select your Y, which is stars. And if we go over here and down, oops, I should go up here. We're looking for the R, and here R is negative 0.76, so that's still a pretty good line of best fit. It's kind of close to 1, and let's write that down. Okay, and it says use your line of best fit to calculate how many stars are visible if, I should say if the humidity is 71%. So again, we have our equation, and it was 67.2 minus 0.59x. And here, x is the humidity, so I'm just going to type that in here. So our humidity should have been 0.7, not 0.71, just 71. Okay, so that now we just plug it in. So we have 67.2, again I'll hit Scratchpad, 67.2 minus 0.59 times the humidity, which is 71, and we can see about 25 stars are visible, about 25 stars. All right, so today we're going to practice linear regression one more time. look at correlation coefficient, and review.